Yay, hello everyone. I hope we are all well and doing fine. Steadily but surely, here we are. The fourth week is done. We have 2 weeks to go to make our complete 6 weeks of, our first cohort teaching levels 100 and 400. And I think that we have so much to be thankful for. This is UGRC150, the target groups that I am engaging now between June to August 2021. My target groups are Group 2 main campus and Groups 3 and Groups 4 city campus. So I teach Group 2 main campus and city campus Groups 3 and 4. My name is Dr. Mrs. Nancy Miles Bakpo-Jimfi. It means if you see Dr. Nancy Miles somewhere, I'll be the one, like I've always said. But then when you see the Mrs., then it means it will include the married name. For several reasons, I mentioned that. Okay. Now, some of you, like I've always said, confuse the groupings. Group 3 main campus is not directly under my immediate supervision, at least for your continuous assessment. So I'm teaching groups and they have names, you see, but you do not expect that what is true of Group 3 or Group 5 or Group 6 main campus should be true of Group 3 or Group 4 city campus, where the lectures are different. I say that also, for my other colleagues, because you cannot go to my colleague expecting to see an assessment that I set for my specific group, and vice versa. Clarify that by going to your course site. Okay. Content-wise, we shouldn't have any issues at all. In fact, for the second part of your studies, I mean your unit 6, 7, 9, and 10, which should be your focus for the next 50% of your assessment, you should engage all content from all the teaching faculty for the various groups. Why? Because we will all together assess you. Unlike the first part, which was a little bit more, lecture or group specific. So you would have to toe the line of the kind of assessment that that lecturer or senior lecturer intended for you. Okay, so these are preliminary comments that should help you get some perspective. The content are the same. That is why they are there. They are not restricted to anyone. But when you have expectations, like you're looking for quiz 1, where is it that Doc, I've not seen the IE? Meanwhile, maybe that instructor hasn't opened his or her IE yet. So you can't make such demands of a person who is not directly assessing you. The same way that you shouldn't come asking me for, say, I didn't see the quick, what is the thing? Pop quiz. If I haven't opened one, you won't see it. So how do we check it? We all go to what? The course site. Your course site, specific to your campus, specific to your group, not what is parading on WhatsApp platforms all around. It might not be helpful to you. It might be Group 3, but not Group 3 City Campus. Or it might be Group 2, but not Group 2 City Campus, and so on and so forth. I thought I should clarify that, especially now that you are getting into final exam. So you should go to the course site and read all announcements there, and you will do fine. Go to resource 2 for my groups, the groups I'm targeting now. I can speak that way. If you are studying the content from another group, it might not apply. So do not go disturbing my colleague that I have gone to the resource 2. I didn't see the YouTube channel that he said is it. Perhaps that instructor is not using the YouTube channel, but it's also giving you links so you can get home and you look at the rules of your home and you will do fine since our focus ultimately is the same. All right. So unit 7 now, because I have given you 3 presentations, I cut them into chunks. For unit 6 alone, I've given you 3 such presentations, part 1, part 2, part 3 on the channel, and then the links copied to your resource 2 on Sakai. for that specific campus that I am teaching this semester. Okay, if you go there, you get the links. If you subscribe to the channel, then you will always get a prompt. When the prompt gets to you, as soon as I do an upload, it might be from my other courses that I teach for different campuses. But if you check and the prompt is telling you that it is something for UGRC150, then you engage it. And I have included some of our very good question and answer sessions also. So you should engage everything I have. If I have uploaded it for UGRC150 at the playlists, you should go there and engage it to be useful for you. Okay, then bring me your questions. Someone wanted my number. I was amazed. I said, are you my group? Even if you are not in my group or you are not a student of mine in any way, I always include my WhatsApp number on every email I send, on every content I produce. So currently on the screen, you would see my WhatsApp number. That's my email. Okay, just so that students can quickly refer directly to us when they need help. Your TA's contact are also on the course outline on Sakai, on the WhatsApp platforms officially created. How do you get the link? It is on Sakai. Go to the first introductory announcement, So maybe to put everything in simple terms, go to Sakai. By this time, if you have not done that, you are not helping yourself at all. When you go to Sakai, go to overview first and look at the whole information there. Then go to resource 2 and get access to every content that has been uploaded. There you will get links because we don't have enough space to upload everything directly. But you get a link that will take you to the source. Then at quizzes, you should by now have done, I'm referring to specific groups here that I teach. Do not go disturbing colleagues who may not have read there or have passed that, okay? So you go to your quizzes, you should have 2 quizzes plus 1 midterm. Each quiz is worth 10 marks and then the midterm test is worth 30 marks. If you did all those 3, you should be counting your 50% already. When will they be released? The announcement says all of that. I'm forced to have to repeat them in videos because students will keep asking you something you've communicated on. If they would just read the announcement posted. There is a specific date that all assessments, my dear friends, that you are doing for me, moi, my name, I have a name, Dr. Nancy Miles Jimfi, not some other group 3 or some other group 4 or some group 2 you have in mind that you think you are in, respectfully, but the group that I pretend over, okay, for the current purposes. If you go there, I can speak to what I have uploaded there. By now, on that specific date that I don't want to repeat here, all the assessments will be released for correct answer, the one you chose, the mark awarded for it, and what you got for that specific quiz. When you total all, you get your over 50, and then you can patiently now focus on unit 6, 7, 9, and 10 for what? Your final exam. I've said everything that I think needs to be said. So this unit will now give you content on unit 7 because this will be co-examined by faculty, the team teaching. It is in your interest to study alongside the required text. This will help you, but you should find the required text because my emphasis may not necessarily be that of my colleague or the other. You want to get an A, you want to do very well, so you should study alongside, maybe even engage some other content that are accessible to you. The outline for unit 7, there's so much in there, so I pray for grace for all of us, for yourselves to be able to absorb all the different things that you have to know. But if you study this strategically, I suppose that you'll be able to cover some good grounds. The basic principles of inductive reasoning. I need you to be looking on the screen because I'll be highlighting and emphasizing here and there for understanding. Okay. What else should you know? That's the outline I'm giving to you. The difference between verifiability and confirmability. Here, we just need you to take note of the words, the language. Okay. so that when you don't think that verifying something is the same as confirming something. No. So that is all we want to show you there. It has to do with the reference class, like I said, when we were engaging particular statement versus general statement in the previous Unit 6 slides. I stressed that you will need that understanding for the next topic. So if you haven't engaged those ones, the 3-in-1 presentations for Unit 6, I think it is a good time to do that. Play it, hear it, then it will form a good grounds for you to build on for Unit 7. Okay, then there is enumerative induction, from the word to enumerate, to count. So you are doing an inductive reasoning, but it is a certain type where you count your evidence to arrive at that claim, which is inductively arrived at. Okay, we can have the instance where it is law-like, your conclusion, so to speak, and then another instance where that conclusion, we say conclusion to help you, but it is actually a hypothetical. The hypothesis could be law-like or statistical when we are dealing with what an enumerative induction. Then in these slides also, of course, I'll cut them into chunks again, but we top it up with causal reasoning, which is in your Unit 9, and the notion of causation. We will build that up with J.S. Mills's methods of what causal reasoning. Then what we will engage some causal fallacies. So you will see that the slide is, the PowerPointer is labeled Unit 7 and 9, but the two together will be cut into chunks. There's a reason why I do that way, for coordination. Causal reasoning is a type of inductive reasoning, just like sampling and analogy, which you would have done in Unit 8, but you will not need for the exam. So when you put them together, you are able to use examples of cause and effect reasoning to emphasize, to show induction, and vice versa. That is why you see them together. So we can proceed. You know the outline now. We will quickly move on, and then when we have enough, we'll pause and build on it. Now, recall induction. Unlike deduction, on your screen now, you see, we said for deduction, if the premises were true, the conclusion must also be true. Otherwise, you create a contradiction. That is not the case for the other type of argument that we saw in Unit 6. The other type of argument is what? Induction, where you induce the conclusion. You force the conclusion onto the premises. You didn't take it from it. You're forcing it on it. So we give several instances. 80% of market women like money. Dr. Miles is a market woman, so she likely will like money. That is a good inductive argument. Why good? Because 80%, then the chances, the probability is high. Yet it is not a certainty. This is a probability because Nancy could be part of the 20%. So for an inductive argument, the premises only provide some good reason or evidence to believe, take note, it's italicized, to believe that the conclusion will be probability true. What should you take from that? When you reason inductively, it is not a question of certainty. There is no certainty established. It is not a proof. It's not 100%. The conclusion you are drawing, that's why we are careful not to call it a conclusion. And you see in a minute, we call it hypothesis, where it is a generalization. Okay, so the conclusion you are drawing will not necessarily follow. It's not a certainty. Even if we granted the premises to be true, the conclusion need not necessarily follow. So we say that is an induced conclusion. It's an inductive argument. You can say it the same way. You can say the premises do not prove or guarantee the truth of conclusion. We have proofs when we are dealing with what? A valid deduction. That is when it will be a proof. not when you are affirming the consequent, for example. We learned that that is a fallacy. It's a deduction, okay, but it's not a valid one. So you may not want to call it a proof, okay? So even for deduction, we could have a deduction that doesn't constitute a proof. How much more induction, where you are not even taking the conclusion from the premises, okay? So there is no logical relationship between the premises and the conclusion of an inductive argument. We don't care whether it is a very good inductive argument that's strong enough or a weak one. It will not be a proof. Why? Because its premises do not prove or guarantee the truth of the conclusion, even if we granted that the premises were true. Okay? That's the same way of saying the conclusion does not necessarily follow from the premise. The meanings of the content or information provided matters when we are dealing with what? Induction. Okay? Because it helps us to determine how much the conclusion is likely to be probably true. You see that? We want to see, did you say 80% of women are so and so, and Nancy is a woman, therefore she'll be so and so? Did you say 80% or you meant 10%? You see, for induction, we would want to know, was it all women have done so and so? So for induction, we look at the content. I say all mangoes are fruit, and this table is a mango, therefore it is a fruit. This will be okay deductively. We don't care what the content really is talking about. We don't look at it at all. We can replace a deduction with variables. Nothing will change. All we look at is the form and the pattern. For induction, you cannot do that. You look at the content also. We examine the content. That's why people might think that induction is probably more difficult to analyze than deduction. For deduction, you just apply the rules. If it doesn't obey the rule, you kick it out. 2 plus 3 equals 5. You can't say 5, 5, tomo. You have 5, 5. No. 2 plus 3 is 5. You put down 5, we take it correct. You put down something else, it is wrong. It's a deduction, sort of. Okay. Note, conclusion may be false. Still on what we mean by induction. The conclusion may be false even if it is assumed that the premises are true and no contradiction will be created. So I think that these various ways of putting the meaning of induction would help you very much. You can always play back to revise what I have said and then enrich yourself. Now, the more evidence you have, I'm still building on how you should understand induction, because the whole unit 7 is dealing with what? Inductive reasoning in the sciences and everyday life. And when you hear science, it's normally the empirical study, even though there are deductive studies aspects of science. When you hear the empirical studies, empirical sciences, then it means our focus now is on what? The observation-based science. Okay, so the more evidence you have that corroborate the conclusion, the higher the degree of confirmation. You only increase the likelihood of truth. You don't establish the certainty of the proof, regardless of the number of evidences you have that support the claim. So you've been with Kwame, he broke your heart. Kwame was a man, he broke your heart. You were with Kofi, he also broke your heart, and he's a man. You were with Achu, he was a man, he broke your heart. Then Aziz also passed by. You loved him small, he broke your heart. See the number of evidences, so I keep adding. So you can add and say, I have all these 17 guys that I dated. They were all guys. They broke my heart. Therefore, you conclude, therefore, for you, all men are heartbreakers. Now, we are saying that if you keep getting more instances of men that broke your heart, it only increases the degree of confirmation. You are adding to the likelihood that your claim that all men are heartbreakers. It's true. You are just increasing the chances that this claim might be true. You see? But you haven't proven it. In other words, You can bring 1,000 instances of guys that broke ladies' heart to ground your claim that men are cheats or men are heartbreakers. But regardless of the number of instances you have that support it, you still haven't proven the conclusion. Why? Because it is still possible to encounter Mr. Johnny Bravo, who is not like them, who will be the exception to the rule. That's what we call the counterfactual. And so if it is possible to encounter a counterfactual, then this counterfactual can nullify your claim. You have 100 people that broke, 100 individual guys that broke your heart. Okay, that increases the degree of probability. Probability will never be equal to 1. It will never be certain. It will only be maybe from 60%, then go to 70%, then go to 80%. But you will never ever get to this, the absolute. Why? Because if you just encountered one Anklata who is the opposite to these guys, who will love you, be there for you, and never broke your heart, then that's your general claim that what? All men are cheats. That's your universal generalization will immediately become false. With just one instance of a man who does not cheat like the others, just one instance of a counterfactor, of a negative or evidence, cancels your hard work. So if all metals expand when heated, you have several instances to show. Watch what I said. I didn't say to prove. You have several instances of metals that confirm that all metals expand when heated. How? Your copper earring, your brass saucepan, your whatever, they all, those individual ones, they all expanded when heated. So you conclude, therefore, that all metals expand when heated. This claim, all metals expand when heated, which you arrived at how? Based on the specific several evidences available to you. You see that? You have arrived at that conclusion, a generalization. We tell you that that generalization has only been confirmed with all this evidence you have. There might be 1,001 specific metals that expanded when heated. And therefore, you want to conclude that all metals expand when heated. Our problem with the reasoning is that this your conclusion is only a confirmed claim. It's a confirmation. Highly probable, perhaps. But you cannot say it is a certainty. Why? Because of the potential of encountering a metal that will tell me I will not expand when you hit me. No matter what you do, that metal now nullifies your claim. So there is always the potential of falsification when you are dealing with what? Corroboration of evidence. So you could get Mr. Johnny Bravo, who will now come and will be all good and will never hurt you. So that your claim that all men are heartbreakers will be nullified. Even though, remember, you already had 99 examples of those who broke your heart. But if only one counterfactual is discovered, it can negate a universal generalization, which was the conclusion you drew after you compiled evidence. See that? That is why we say you may have confirmed something, a generalization, but confirmation is never the same as proof. So far as there is a possibility of falsehood, you can only say you have confirmed it, like the COVID cases that we've had, but there can always be a counterfactual, and that is the case. All the planets may move around the sun, all the planets, those you know now. So you can conclude all planets orbit the sun until you get a planet by your investigation that says, I'm not orbiting. You will then come home and revise your general claim. So you might have confirmed so many things, but it is never a proof. Anytime people have fibroids of this size in the past 30 years of your experience, there are about 13,000 women that you have checked as a gynecologist, who had such and such and such scenarios of fibroids, never made it. They never gave birth. 13,000 plus, that's quite a number for 30 years, so the guy is experienced. But he cannot claim that therefore women with fibroids X, Y, and Z shape will never give birth. That claim is a certainty. No, it is not. We may find an X woman who may have those kinds of fibroids, but because of a certain other factor in her system, would be able to give birth, and maybe even give birth to triplets or quadruplets. I mean, without any stress. So that woman's case will then be a counterfactual, to the several research that already corroborated that claim. You see that? That is why it is not a proof. So when you are getting several instances that support a generalization, we work with it. We manage with it. We say that anytime we throw a ball up, it will come down. All those are scientific generalizations. But we are careful always to anticipate the possibility of what? A counterfactual. That is the rationale behind scientific research. That's why we go and search again. Research. We have searched, but we go back and search again because we are hoping, we are thinking that we may find something contrary to what we know to be the general case. You need to get that, because if you get that, then all the other things are just ingredients that fit into the discussion so far. Types of inductive arguments, therefore. I just stressed a bit on confirmation is not proof for your practical work. As for the marks, you will earn them, I am confident. But you must see the impact that this thinking will make on your research. Types of inductive arguments include which ones? Sampling, analogy, causal reasoning, enumerative induction. We saw types of deductive argument. They included modus ponens, modus tollens, and the others that you so well know now. You should be practicing, you see. But now, here we have sampling, analogy, and the like. And your textbook and the focus for us as a teaching team would be causal reasoning, and that we will add to, we will not include sampling, but we will do causal reasoning. Okay, examples of inductive arguments. So let's see. I'm sure by now you have seen them all. 80% of politicians are lawyers. Mr. Kofi is a politician, so he's a lawyer. Obviously, even if we accepted the first two as true, it doesn't necessarily mean this conclusion will follow, you see. So that is it. The second one, few Ghanaians are hostile to foreigners. The day is a Ghanaian, so she's not hostile to foreigners. Look at this. We said few. Now we want to say she's not hostile. Few Ghanaians are hostile to foreigners. Dede is a Ghanaian. If we ourselves are saying few Ghanaians are hostile, and we say Dede is a Ghanaian, then she should rather be what? You get me now? Even if we accepted these two as true, I'm getting a bit distracted. Close the door. Open the door. Then we would say that even if these two were true, it doesn't ground the third point. Then question 3, is a woman and she cheated. Ajo is a woman and she cheated. Mansa is also a woman and she cheated. You see, there comes the conclusion. Therefore, believe me when I tell you that women are cheats. Now you see that this is also inductive. Why? Even if we accepted all the premises as true, we will not necessarily have to accept the conclusion as also true. Otherwise, we will, what's the problem? What's the issue? Otherwise, we will commit a fallacy. This is a good example of an enumerative induction. Okay, so let me chip it in now. Then when we get there, it will only be revision for you. See, you enumerate your evidence. The reasoning is induction. You are inducing. What do I mean by that? If I accepted all the premises as true, even if I did, I will not be obliged necessarily to accept the conclusion that comes with it. So it is an induction, it's an induced argument. Which type of induction will this be? I'm saying that it is an example of the one we call enumerative induction. You enumerate, you're counting your evidences one after the other. From Ya, who cheated, to Ajo, who cheated, to Mansa, who cheated. And this can go on and on and on. That's most of the time the reasoning behind scientific research. See, we got Asimesi, came to the hospital, we saw some symptoms X, Y, and Z on him. It was COVID. And the next person also came. We saw something similar to that, COVID. And the third person, something similar to it, COVID. We won't wait till the whole world gets infected. We will say we have a signal that there's a new virus in town. It might be, I mean, some of them may not be, but at least we will blow that alarm. So the reasoning is what? Enumerative induction. The more numbers you count, the higher the probability that there is something inside it to look into. Okay. Then look at 4. 2 out of 5 women like rich men. So women like rich men. This is also inductive. Look at my conclusion. I said women like rich men. But you said 2 out of 5. Even if you said 4 out of 5, you cannot therefore conclude that women, that is all women. There will be the possibility of an exception, even if the premises were true. Okay, that's what makes it inductive. Then the last one, which you have seen already in our past readings, even if the security man was the last person who left the room, we cannot certainly claim that he was responsible for the theft. I put some practicing focus for you. You'll find it in your textbook. I'm not sure about the page number, but you can get activity 1.5 of the unit 7, distinguishing deduction from induction. You can go to tutorial and prompt your TAs to walk you through it. They are practice questions. The answers are there, but it is not enough to imbibe answers because you may not see the same questions and you likely won't see the same questions from the textbook, but you should know how to fish. And then when we put you somewhere, you can fish for yourself rather than waiting to be handed fish all the time. So make an effort at understanding why the supposed answers they have been provided. Then no matter the twists and turns we put to it, you'll be able to respond. Okay, so on the screen now, a typical example of an enumerative induction. Why is it an induction? Look at all these premises. I dated Amma, I dated Ya, she also cheated. I dated Mansa, she cheated. My special student. The reason why I'm reading through it, I dated Afi, she cheated. I have just dated Zainab and she cheated. All the women I have dated cheated. Take note that even at this stage where I'm highlighting now, all the women, this is still a particular statement. I hope you remember because I'm referring to the women, specific group. Don't look at the all. Look at the reference class. What am I referring to? All the women I have dated. That's the reference. So this is still a particular statement. So where is the conclusion? The person therefore concludes, so all women are cheats. I'm moving from these particular statements, which I can accept to be true. Each one of them could be true, and yet the conclusion that all women are cheats does not necessarily follow, friends, because my pastor's wife may not be included, or myself may not be there. So I may accept that it's true that Ya and Mansa and Ajwa and Nafi and Zainab cheated and they were all women. I am not obliged necessarily to accept also that all women are cheats because this is bigger. It includes women of all times, all places, yet to be born, dead and gone, babies that are going to grow up to be girls, go to SHS before they become women, are all included here. How do I measure that? So this is a generalization, a law-like one. We have met all that already in Unit 6, a universal generalization. So if I move from accepting all these premises to be true, and yet I am not obliged to accept the conclusion that it comes with, then the reasoning is an inductive one. Which type is this? The one we call enumerative induction. We enumerated, we counted to reach where we are. So I have put a note under for you, premises, verifiable statements are listed or enumerated to show the several instances that support the generalized conclusion or hypothesis. You see, so this conclusion of an inductive reasoning, you see, we don't want to say it is concluded. No, because it is inductive. There's still work to do. You further, for this one, you will further do what? Research. It is not a certainty. So we would prefer to call it, since it's a generalization and it is the conclusion of an inductive argument, we would prefer to call it a hypothetical statement, hypothesis, rather than to say a conclusion. If it is in deduction, we can straightforwardly say premises leading to what? A conclusion. But for inductive reasoning, the language is a bit softer. These are evidences leading to what? A hypothetical claim. Each of the evidences can be verifiable. Remember, particular reference class, unit 6, is verifiable. It means it is directly testable. You can pick that specific armor and check if she cheated. If it is a metal, you can pick that specific earring or that specific saucepan cover and drop it in fire and see if it will expand when heated, that specific thing. So it is verifiable, it is directly testable. Why? Because it is referring, the statement is referring towards a specific reference class, a particular statement, a countable reference class. Okay, go back to the unit 6 and refresh your memory there. How about the conclusion? What we have here, which we have said we should label as what? A hypothesis. Can we even have all women? No, some are not even born. Some are dead and gone. This is infinite. The reference class is infinite. We have seen that. Uncountable, potentially never ending. So you cannot use the word verifiable because you can't even directly test. So this expression is indirectly tested. How? You test it through its subset. You pick some few women, then what is true about them, you project and hope and trust that it will be true of all women. It may not be. We have seen that already. Okay. So you directly test particular statements, but you indirectly test confirmable statements. Okay, I'll say that again. For particular statements, how? How do you know that? Reference class. Okay, you directly test them. For generalizations, like this one and the other one, you know there are two. This is a universal generalization. I could have said 80% of women are cheats. It is still a generalization, just that it's a statistical one. So revise unit 6 again. Whether statistical or universal, we test them indirectly, and therefore we don't say we are verifying. No, we use the word confirming. So we can confirm generalizations whilst we can verify particular statements. Why? Because particular statements are directly testable, whilst generalizations are only what? Indirectly testable. Both of them are testable anyway. They are all scientific statements. They can be either true or false. They have a truth value. Okay, so whether general or particular, they are statements. That simply means they have a truth value, unit 1. But then how we test them differ. And therefore, the labels are also different. Two kinds of enumerative induction, still guided by our course outline. Remember the outline we put up there. Okay, so this one, no big deal. Where the conclusion, like the earlier one we saw, was law-like. After we saw all the several particular instances, we make a general claim. Therefore, all women are cheats. Therefore, all metals expand when heated. That all metals expand when heated, see on my screen now, is what we call a universal generalization. And therefore, an enumerative induction could end, you see, could conclude with what? A law-like hypothesis. Or sometimes, after all your particular instances, you still make a safe, hypothetical statement. You draw a hypothesis that is safer than a law-like one. That one will be what? Statistical. It will still be a hypothesis because your reference class will be infinite, but it ends with what? A statistical hypothesis. So take note. Hypothetical statement could either be law-like or statistical. Okay. Now, on your screen now, then you will see an enumerative induction that ends with what? A law-like hypothesis. This is just a sample. We didn't need to even do all of it. Just like the Amma is a woman, she cheated. Yeah, followed with the cheating, and then Kojo to excuse me. And then Zainab also came to cheat. The same thing here. We are giving a little bit more scientific example. So gold expanded when heated. That is what premise one. You could say the gold plate expanded when heated. The silver spoon expanded when heated. The bronze ring expanded when heated. The copper iron, copper what? The copper doorknob expanded when heated. So these are particular things. They all expanded when heated. So and remember, they are all metals. Gold is a metal and it's expanded. This is a metal, it's expanded. Zinc is a metal, it's therefore it will sound highly confirmed. The probability will be high to say that all metals, this is the real conclusion. Look at the conclusion I highlight over there. It will sound good to say that therefore, see, all metals expand when heated. This conclusion drawn here is a hypothetical statement. Why? Because the premises grounding it are not conclusive. If we even granted all of them to be true, it doesn't mean all metals expand when heated. And we already know metals that are so recalcitrant, they won't expand when heated. Why? Those are the ones you use to do your very good rings or whatever. Okay. Then an example that shows a conclusion that is what? A statistical hypothesis. And that is rolling on your screen. I think I only repeated what we saw over there. Look at the conclusion now. I dated Amma and she cheated. I dated Ransa, all of them. They all cheated. Therefore, see what the person says. Most women are cheats. And conclusion here says, therefore, most women are cheats. Now, you will see that this is also a generalization. Most women, which type of generalization? The statistical one. Reference class women of all times, all places, born, yet to be born. So it is a generalization. But which type? The one that makes exception to the set. It leaves some people out of the reference class. So if I say most women, few women, 2 out of 10 women, the women in it is what is making it a generalization. But that I left some out of the set will determine the type of generalization. If I left some, then it is statistical generalization. If I included every member in that general set, then it will become a universal or law-like generalization. Okay? So most women are cheats. It's a statistical generalization, and that is likely to be true, given this evidence, than the one that said all women are cheats. So in terms of probability of truth, statistical hypothesis will be higher in terms of what? Probability of truth, likelihood of it being true. This will be more likely to be true than the universal one. I hope you are following slowly. So it will be amazing that yet for the scientist, the empirical scientist, the one that is easier to be false will be appreciated and valued than the one that is easier to be true. Why? Why would a scientist, the empirical scientist, value law-like or universal hypothesis than a statistical one? One can easily be true than the other. Yet the scientist would prefer the one that can easily be false than the other. You can write that question somewhere. I'll get to it. It is because of the content one carries. This one, the statistical hypothesis, is talking about most women, not all women. So most has some content. The reference class is big, but not compared to all. All is talking about plenty. All gives you more information. It's called empirical content. All gives you more information. It's called empirical content. All tells you that you can predict. When I say all women are cheats, as soon as you see a woman, you can tell by prophetic unction, there comes a cheat, there comes a cheat, there comes a cheat. You don't need to be guided any longer because oh, so it informs you better. All metals expand when heated. If you know that the ring you are wearing is a metal, and you know that all metals expand when heated, as soon as you start getting near heat, you might take it off. If you want to do something abrasive with powder, you will take it off and protect your ring because you know that if it gets near heat, it will expand and the shape will go bad. Oh, so there is no exemption. The scientist aims at doing what? Giving you information that will help you predict how to manage yourself in a world that you didn't create. We are studying nature. That's empirical science. So the type of generalization that gives us more empirical content, you should write that down, is important to the scientist. The one that gives you more empirical content can give you more predictive power, the power to prophesy and say the right thing, not the one that will say something will go and win and then will frustrate our lives. This one, it will give you the ability to predict when you know that all women deliver in 9 months, for example, compared to most women deliver in 9 months. Which one informs you better? If you know that all women deliver in 9 months, then that house girl that has changed color, you can't see her very well. You say, oh, don't worry, 9 months, baby. How do you know that? Because it is presumed, by the research that all women deliver in 9 months. So in 9 months' time, you will see how far. You're able to predict when you see water, a flood of water, and then some electricity wire falls inside and the lights are not off. You know what that means. You will have to start moving from there because the water will conduct electricity. All water is a good conductor. I say it's because water na water, okay? It's a good conductor of electricity. Oh, whether soapy water or maybe the scientists can help us out there. So if I know all are this, it tells me more than if I know most are this, even though they are all informing us. That is actually the thinking behind the value of scientific statement. So the scientists, take note of it now because it is important for your own research, not just to pass an exam. It is important for an empirical researcher if the findings are generalizations than if they are particular statements, because it helps you to be properly formed. You get empirical content, information about the empirical to aid your predictive power. You can predict who will win which position, political scientists. How do you do that? The more data you gather that capture a generalization, the higher your chances, of prediction. You can predict. You can predict. How? So if I say all X are Y, that's a universal or law-like generalization. It is more valuable to the scientist than if I say some X are Y, even though both of them are generalizations. It means that particular statements are less valuable if you compared it to statistical generalizations. And statistical generalizations will also be less valuable to the scientist compared to universal generalization. That is the order. So the first would be universal generalizations. Next would be statistical generalizations. Then we'll come to the verifiable statement, a particular statement. Okay. Why did I go through all that? To show you that the fact that a conclusion or a general statement, let's say it that way, is easier to falsify. This one, the one on the previous slide, which is easier to make false. You see, the generalization, the universal one, is the one that can easily be false. So it has a higher falsifiability. That one is rather more valuable to the scientist. Okay, the one that is easier to make true is not too useful to the scientist. It doesn't help us to get informed. How do you make it simple in your mind's eye so you can absorb? Look at the reference class. The more content you have in the reference class, the higher the value. So if one reference class is speaking about coffee specific, and the other reference class is talking about all the boys in this class, and then the third one says all men, you will see that the scientist, empirical scientist, will value all men more than what? The men in this class. And then that one also what? More than what? Kofi has done so and so and so. That is the degree of falsifiability, and the contrary view will be what? The degree of what? Probability of truth. Well done. I will add some little thing here, and then we will cut this into some piece and then come back again. Now, what do you see here? Confirmation is not proof. I've said all of this. So the slide is only projected here for you to see. Okay, hypothesis is the same as the conclusion of inductive argument. I've said all this. All this I've said, confirming, proving. Confirmation is not proof. I've said all of that. Okay, now verifiable versus confirmable. I've said all of this. Now look at it. Let it just sink. Verifiable, finite reference class, directly testable. All these are referencing what? A particular statement that has a finite or specific countable reference class. We have said all this. So that man is a bully. That man, I'm referring to only one. It is scientific. It can be either true or false. That's what we mean when we say it's scientific. It is testable. You test it because it can go left or right. It can be true or false. So that's fine. But the value of this statement, that man is a bully, is less than the value of what? Men are bullies. I'm pointing on the screen, so you should look at it. Men are bullies will be more valuable to the scientist because of the reference class, this one. It contains so much content. Many men at all, compared to this one that says that man. Okay. So verifiable up, confirmable down. This is which type of generalization in our discussions you should bring them up. This is a universal one. Okay, it is also called a law-like. It is like a law. I said all of that. This is confirmable. See, if it's confirmable, then it is indirectly testable. Why? Because it has an infinite reference class. It is a general statement. The reference class cannot be counted. All these have been said. Okay, they are just there for emphasis. Q. Then I took you back to some of the things I said already in your unit 6 slides. You see that they are repeated here. It's just an emphasis. So you go through them again. Remember all this universal law, like some men are bullies. Why? It is a generalization, yes, but what type? The statistical generalization. So all of that in your unit 6. The reference class tells you whether a statement is general or particular. Then it will even go ahead and tell you the type of generalization. We have said all that. Even if you didn't listen to that one, in this very lecture, I have emphasized that a bit more. Now, just some few terminologies, and that is what I said God should give us grace so that you can remember them all, okay? You will see that particular statements are very useful as evidence. When you are doing inductive reasoning, your evidences are better off when they are what? Particular statement, when they refer to specific, so that the people can test it to support the baggage you brought, the hypothesis you brought, you see. So your premises in an inductive reasoning, if your premises are particular statement, then it makes for easy directly testing. See, you can easily test it directly. For premise. Remember, the premise is coming to give support to someone. So it shouldn't come with doubt on itself. You don't have to do too much work on itself. How will you do it? You should come with Amma is a cheat. And she's a woman. Yeah, is a cheat. So we can take Amma and check. Yeah, and check. Okay, Adwa and check to help us support our claim that all women are cheat. So your premises in an inductive argument are stronger if they have what? Particular reference, if they have finite reference class, that is if they are particular statement, okay? Then your generalization, I've said all of this, see, generalizations or general statements having finite reference class, they are indirectly testable and therefore useful as hypothesis. If you use general statements to form your premises, then before you conclude, you say all women are cheat and all women eat this, therefore all women are. How will we ever finish testing that truth? It will be highly improbable. Remember, For induction, we are just increasing our chances of probability. So everything you can present that will make testing easy and verifiable, rather than you bringing us a baggage of confirmable statement. Now let's try our hands on this. You saw this earlier. Now it will make a bit more sense to you. You have seen it in the slide. The disease is contagious. Is this confirmable or verifiable? The disease is contagious. What's the reference class? The disease. So this is verifiable. It is a particular statement. The reference class is countable, the disease specific. So we can verify that. We can test it directly. And so it's a good evidential statement. You can use it as an observation statement to go and support a hypothetical claim you are making. Okay? That just means you can use it as evidence to support a hypothesis or a conclusion in inductive reasoning. Look at the next one. Few Ghanaians are allergic to pineapples. Few Ghanaians. This is not a particular statement in Yanum. This is a generalization. Ghanaians of all times, all places, yet to be born. That's the class. We only qualified it and said a few. So if you are Ghanaian, you will 10. Then you look at the few and say, okay, maybe I'm not included, but they are talking about Ghanaians. So this is a generalization. Which type? Statistical one. If it's a generalization, whether statistical or not, like we have said it, then we do not verify them, we confirm them. So this is a confirmable statement. Third one, the liquid in that bowl is poisonous. Verifiable. Green tables are scarce these days. Look at this is from your textbook. Direct, dito. Green tables of all times, all places, yet to be designed, not yet designed. They are all included. So this is a generalization in Yanum, which is a law-like one. Doesn't make exceptions to the rule. You confirm this, you don't verify. That simply means you indirectly test it, you don't ever get to test it directly because the reference class has many members, some not yet even present. Kofi is the new SRC president. This is directly testable. Kofi, specific, direct, countable, finite, verifiable. 6 and 7, I told you in the other video, all voters prefer a recount of ballots. That's confirmable. Why? All voters. I said all that in the previous one. Especially if they don't do. Those who vote, this is what I'm saying. Anyone who votes prefer a recount. This is a generalization, a universal one, referring to 6. Now look at 7. All the voters interviewed said they will prefer a recount of the ballot. All the voters interviewed. This is not a generalization. Even though it started with all, I have a specific group in mind, which group? The voters interviewed. Okay, there might be 100 million voters. We will finish counting because I said there. I have a definite group in mind. Look at 8. No student registers unless forced. So that's a confirmable statement. This is just saying that if X is a student, then X will never register unless they force them. Remember, universal negation. This is a universal statement, a negative one. If antecedent, then not consequent. A disjoint set. Remember when we did modus tollens. It's a confirmable statement. Then 9, none of the students in that class registered for the course. None of the students in that class. This is a particular statement, and therefore we verify. Then the very last one, 80% of all retailed stones. See, all retailed stones. If I had said 80% of all the retail stones in my shop, that would have become a particular statement. 2 out of the 10 retail stones in my room, the 10 retail stones, you see that? But if I said 2% of retail stones are not diamonds, see that I'm referring to retail stones of all times, so all places. Just that I want 2% of that infinite set. Whatever the infinite set is already not specified. That's why this is a generalization. Then, so the 2% input, how do we quantify that? It is still a generalization. Yes, there is a statistical one. So we will say that one is also confirmable. Good job. Would it be wise to top up? Let's see where we are. We may have to cut this into some bit, and then I follow up with the next one. I don't know which one helps, because sometimes when it's too heavy, then studying it becomes, let's round it off nicely, then we can look at the next. We still have a few more slides to go, more than half. So let's see, we will continue from here. I was going to show you degrees of confirmability, which I've talked about anyways. Examples of statistical hypothesis. Do you remember? Some Americans are allergic to pineapples. This is a generalization. It's a hypothesis. Somewhat Americans, all time, all places, etc., except they are qualified with some. So it is a generalization of the statistical type. So this is confirmable. 80% of all retail stores, we've seen that. Most Christians worship on Sunday. It's a generalization. It's not particular, yet it is what we type, a statistical one. Few Africans approve of same-sex marriage. That is also a statistical hypothesis. 2 out of every 10 men are egoistic. 2 out of every 10 men. So the reference class is all of that. Men of all times, all places, qualified. You see that. So this is statistical hypothesis. I hope that the examples bring it home for you. How about the law-like ones? We have some universal negations and universal positive. No cat is a dog. All voters prefer a recount of ballots. No student registers unless forced. Ghanaians are hospitable. You see, there are no exceptions to the rule here. And the reference classes are all infinite. So we call them what? Alcoholics are womanizers. Okay, we call them what? Law-like hypothesis, or if you like, universal hypothesis. Note that statistical hypotheses are easier to confirm. I said that. We can easily make them true. Probably true. They are easier to confirm. You should have been happy with that. But look at what it means. It means that they are therefore less valuable to the empirical scientist compared to what? Law-like hypothesis. Why? Because of the empirical content that it carries. I want to end my part 1 of this here so that you can chew and munch on it. I'll do the next one right after this, so there won't be too much long talk. You have to follow it. Will it be helpful to do all together? I don't know how much. Let's continue, okay? So that you don't lose track when you are tracing. If you think it's too heavy, then you cut it into bits. Note degrees of confirmability. Statistical hypotheses are easier to confirm than law-like hypotheses. We just said that. That makes statistical hypothesis less valuable to the empirical scientist. The focus is what? Empirical. It is the empirical scientist we are talking about. If you were dealing with any other scientist, the deductive scientist, the one dealing with meanings and closed concepts, then that won't apply. But those that deal with observation, sociology, psychology, some aspects of biology, some aspects of physics, those who see, hear, touch, taste, smell, political scientists to draw their conclusions. The reason why sometimes our analysis go bad is because of how we are predicting based on the research findings available to us. Okay, so that makes statistical hypothesis less valuable to us as empirical scientists. Law-like hypotheses are what? Rather easier to falsify. But amazingly, something that can easily be made false is rather more valuable. It's of virtue to the empirical scientist. Why? The question is why? When a theory is falsified, then the empirical scientist can be certain that it is not true. When you make it false, we can be certain that then it wasn't true. You see that? At least we know that it is not true that all women deliver their babies in 9 months' time after conception. That's why you can be certain. We are looking for knowledge. See, the scientist is trying to give us information about the world so we can survive in it. You didn't create yourself. You just found yourself living. You didn't decide to be born. You were born in a world that you didn't show where the parameters should be. Fishes swim and birds fly, and human beings walk. Period. If you try to walk on water, you will drown. Principles have been set in a world, and then you have been dropped into it. You want to make babies, you don't punch ATM figures to get them. There's a rule, a principle, a regularity that you found yourself in. So the scientists' work, whether sociology, psychology, economics, political science, what have you, is to discover those laws. The scientist is working at opening the laws. Discover. The thing is covered. You discover it. You open it. And as and when they achieve that knowledge, they acquire that knowledge, they encounter it, then they share. So the preoccupation of science is to give us knowledge that is certain. They are looking for certainty. And how can you be sure or certain about your findings unless it is subject to tests? You expose it to all falsifiability, and yet it hasn't been made false. Okay? So the principle of falsifiability helps to expose the theory. Try and make it false. Let's see. Try and make it false. So if you say all metals expand when heated, you're making it prone to be false. Because if we found just one metal that will not expand when heated, it will make what we thought we believed false. That is why the general claims, especially the universal ones, are useful to the scientist in his quest to discover truth. Now, if for years and hours, and like the heliocentric view that we hold on to now, that the sun is in the center of the universe, it took hundreds and hundreds of years to discover that. We thought it was the geocentric view, the earth rather in the center of the universe. Okay. And then research kept going on and on and on and on to discover this law, which informs several other things in society. Okay. So if we find out that we were wrong after all, in other words, for example, a sickle cell patient could live beyond the 18 years that had been discovered then. If we find out, we can now be certain that it wasn't true after all, what we thought we knew. And that is the target of a genuine scientist, looking for certainty by intentionally exposing their theories. So scientific truths are not dogma. They are not church doctrines where you don't want it to be falsified. No, scientific truth properly done. If you are doing science, you expose it. You expose the truth to possible falsification. So that if it hasn't been falsified, then you want to believe that then chances are that it is true. It is true probability. Okay. But you don't protect theories. The best way to expose theories to possible falsification, just so that you can ascertain truth, is by doing what? Making them general. So after a few instances, you generalize it. 2-3 metals expand when heated. You say all metals expand when heated. 2-3 people in Volta or Ashanti region say, I'll vote NDC or MPP, respectively. You say, oh, Volta people. So that it can help you see whether this hypothetical claim you've made that Hillary Clinton will win based on, there is, okay, all who normally vote red are found at so and so region. That's a general statement. All who do this have done that. When you get that, then now the actual work begins because it has become a hypothetical generalization, a universal one, prone to falsification, whether in econs or whatever. If it is falsified, then you at least can know something true about our empirical world. Okay, so that all I've said is what is on the screen. When the theory is confirmed, when you add to it, confirmed means when the evidence supports what you already said, it only means there is currently evidence that will support or corroborate the likelihood of the theory being true. You still haven't proven it. So more evidence supporting it is not a proof. But as soon as I get one evidence that negates it, like the COVID vaccine, if I got one evidence of someone who has taken the vaccine and yet some way, somehow got the infection and was worse, we will quickly get anxious again because it is the one falsifying our generalization. That is helping science. Karl Popper says, and you're not doing philosophy of science, so don't bother your head. I just want to give you an evidence that will help you. He thinks science thrives and grows on what? Falsification. As soon as a theory is falsified, that one planet will not orbit the sun, there's a revolution. Okay, others think otherwise, and then they debate and bring the theories out. But I want you to see this nomological hypothetical procedure that I am trying to simplify and present to you. So the third point I put there is the empirical scientist cannot be certain that a confirmed theory is certainly true, because there is always a possibility that I've said all of that, of a counterfactual. Therefore, what should you say in your mind? Law-like generalizations are more valuable. Next is what? Statistical generalization. Then what? Verifiable statement. I sincerely have to pause here, otherwise we'll have a long content. I'll quickly do the next one. I'll label it part 2 for unit 7 and 9 so that you can trace it easily. Keep learning and keep having faith. You are not only studying to get A in a course, you will definitely, I believe, with a little effort, get your A, but you need to get the substance of critical thinking for your research work, for your critical ability, when you are engaging people as a graduate of the University of Ghana. You see that your thinking, the way you reflect, how you are advising, how you are proposing should reflect the student that has gone through the course, and that's our target. See you shortly.